Group C for our project, the members were John Kerrigan, Matthew Knight, and myself, Tina Walker. For our group project, we looked at whether there was a significant linear relationship between salaries and gender and ethnicity. The National Center for Education Statistics is where we found our data set for the 1999-2000 Schools and Staffing Survey. This survey looked at 5 major policy issues on teacher shortages and demand, characteristics of elementary and secondary teachers, teacher workplace conditions, characteristics of school principals, and school program and policies. New coverage included school and district performance reports, standards for homeschooled students, charter schools, migrant students, and the availability and use of computers and the internet. This chart shows the sample size and the response rate for public, private, BIA, and the public charter schools. The U.S. Census Bureau performed the data collection and sent letters to the participating schools in August and September. School questionnaires were mailed out in October, and the remainder postcards were sent several weeks later. Follow-up for the non-responding teachers was conducted by the computer-assisted telephone. The main design objective of the school survey was to provide estimates of school characteristics, including the nation, elementary and secondary levels by public and private sectors, BIA schools, and schools with a student population with at least 25% American Indian or Alaska Native, school levels of public schools by state, and private schools by association group, region, and school level. Our dependent variable was salaries, and our independent variables were gender and ethnicity. We chose these variables because we wanted to see if there was a relationship between salaries and gender and ethnicity. Our group believes in gender equality and wanted to see if a teacher's gender or ethnicity influenced the salary. We ran a linear regression with variables listed above. The dependent variables salaries earn all, independent variables gender TO356 and ethnicity TO357. We included estimates, model fit, descriptive statistics, R-squared, and part and partial correlations. The outputs were descriptive statistics, the Pearson correlation, model summary, ANOVA, and coefficients. Our research question was, is there a significant linear relationship between the dependent variable salaries and the independent variables of gender and ethnicity? The null hypothesis would be, there is no significant linear relationship between the dependent variable salaries and the independent variables of gender and race in the population. The alternative hypothesis would be there is a significant linear relationship between the dependent variable salaries and independent variables, gender and race in the population. A multiple linear regression analysis was applied to examine the linear relationship. An alpha level of 0.05 was used for the analysis, and the descriptive statistics, means, and standard deviations are presented later on Table 1. This is our regression analysis equation. This regression equation accounted for 2.9% of the variance in the student math achievement, as R-squared was equal to 0.029. The proportion of variance accounted for in salaries by the regression equation is statistically significant. The DF's at 2 and 42,083. F was equal to 630.465, and P was less than 0.01. Overall, gender had a statistically significant negative effect on salary, where B1 was equal to negative 0.377, and T was equal to negative 35.508. P was less than 0.001, and race had a negative effect on salary, yet it was not considered significant. The B was only a negative 0.012, and T was negative 1.446. Holding race constant with 1 unit increase in gender, a negative 0.377 unit decrease in salary is predicted, while holding gender constant with 1 unit increase in race, a negative 0.012 unit decrease in salary is predicted. We therefore rejected the null. What the findings show is that a significant relationship exists between gender and salary. A seen negative effect was determined to exist between the two variables. With a seen difference in gender, we saw a significant decrease in salary. The same negative effect was seen when comparing race and salary, yet with little to no significance in effect. We find these results to be interesting in how they relate to the terms of equity related to gender and race when looking at salary. It appears that salary has a significant effect on income when looking at gender, but little to no effect when looking at race. If we were to expand this survey further, we feel as though it would be beneficial to see if there is a significantly seen difference when comparing races such as Caucasian, Black, Latino, Asian, Native American, etc. The data remains confusing due to the fact that these differences in race are not separated. A repeated measures ANOVA would be suggested for future surveys. In the table 1, we have the descriptive statistics of mean and standard deviations. Table 2 was the ANOVA with the dependent variable of salary. You can see the F score of 630.465. And table 3 is our estimated regression coefficients, dependent variable salary again. This is the syntax from the upload to the SPSS software. And this is the final output with the model summary of the R squared, the ANOVA with the F score of 630.465, and the coefficient scores of gender and race, the -0.377 and the -0.012.